Welcome to Camper Van Conversion in bite-sized chunks. If you happen to have come across this page through some random link, you might want to click on the link in the top right hand corner to take you back to the introduction to tell you a little bit more about these videos and how you can get the best out of them.
Gas, lives to gas. Right, so I remember when I kicked this video off right at the beginning in the introduction, I said that I ain't going to do no health and safety stuff because I'm not patronising anyone. So when I go through this, I'm just telling you what I did, some pointers. I've got a bit of a healthy respect for gas, maybe a little bit over healthy, some people might say. So some of the things you'll see me doing, you may choose not to. You might think it's a bit over the top, but that's the way I chose to do it. Now, I'll have a crack at most things, but actually I got someone in to do my gas plumbing for me. And actually in the resource library I've put some contacts for mobile gas installers. I was their handyman, so I was the gopher, but I was looking carefully what they did. They probably thought I was a bit of a pain because I wanted to witness the leak testing of every joint, and apparently you don't use soapy water, there's a special stuff you use. If I'd done another van, would I do the same or would I have a go at myself? I might have a go myself next time round. I picked up a lot and I've done a little bit of stuff offline. I'm confident I could do it myself, but I chose to get someone in. As part of my health and safety paranoia, you might argue, when after the circuit was completed, I actually added a feature in the back, and you'll see that, and that's a manometer. So I can regularly test the integrity of my entire system by seeing if there's any pressure drop. Couple of things, a tip I picked up on the forum, and it was bang on, one of the camper forums is, be prepared after you've put your gas circuit in to go back after a few hundred miles and just tighten them up again, just in case the vibration is loosened them off. And apparently you only have to do that once. Second time round they'll bite nicely, and so I did do that. I didn't screw everything down too tight so I could go back in, and I made myself aware that I was going to have to go back and do this when I was building it out, so I didn't have a joint that would never have any access. And on that note, not teaching anyone to suck eggs here, but if you're a regular domestic gas engineer, Corgi, or what it's called Gas Safe now, isn't it? Corgi's the thing of the past. You'll be having no problems doing this sort of thing, but you don't have, it seems in vans you never have Yorkshires or solder joints. They're always compressions. You can get 8mm, because it's an 8mm circuit, you can get 8mm solder joints, but you don't use them in a van, and the reason apparently is because the vibrations can crack the solder, whereas compressions get them up right sort of tension, and those olives hold tight. What else? Liquid petroleum gas, LPG, butane or propane, is heavier than air. And in the manuals, some of the white goods, like for example the cooker and the fridge, it will alert you that you need a dropout, which means under the fridge, if something in the fridge or the heater, so the oven, leaks a little bit of gas, it drops out to the outside air. And you'll see in my design, actually I've got a grill over the wheel arch and ducting, so any leaks from the fridge or the oven can escape through there. Having said that, my manometer at the back always gives me assurance that I've got a robust circuit, and you'll see that in the video in a minute. So I think that's it. Also you'll see in the gas bottle locker, I built my design so rather than have one big bottle, I've got two small ones so I can take them in and out. But again, I've got dropouts there, so in the top of the locker it's open so fresh air can come in. If there was any leak, it would drop out. Actually, it drops into the water tank, then locker, and then down through to the outside atmosphere. So, bit of a healthy respect for gas. That's me. You guys may be a bit more relaxed about it, but let's have a look at a bit of detail on how I put some of those measures in. So that's the gas locker. Two
bottles in there, 4.5 kilo bottles. So one's connected up, it runs out. I just connect the other one up and get it swapped out. And inside that locker, you can see I'm keeping the gas bottle spanner and some cloths and the liquid for the manometer, which you can see in a minute. I choose not to have the gas on at night. I close it down, and actually I can get to the valve to close that bottle off from the inside. That little construction above the locker, the white thing there, is actually access from the cupboard where I've got my water heater stored, a little sort of compartment. Because that's just my paranoia. And I also choose not to drive with the gas turned on. Everyone does it. It's fine. I just have this notion I don't want to do it. So on top of the gas control valve, I have this. And basically, what I do is I take that off and I stick it on the gear knob when the gas is open, so I can't drive away without remembering to turn the gas back off again. There's you can just about see in the middle of the base of that locker a hole. That's the dropout I talked about. If there's any spare gas, it goes into there, and actually that goes into the water locker. And from the water locker, there's a hole in the bottom that goes out into the outside world. So you need your dropouts. And talking about dropouts, inside the in the cupboard units where all the heater is, and in the fridge and the oven, over the wheel arch, I've got another hole. That's what you're looking at there. That takes any sort of that's the dropout for those white goods. And that goes into the outside world. You'll see that in a bit more detail in the kitchen build video. And finally, in the section where the water heater is stored, that grey thing on the left is the water heater. I've got this little gizmo. It's a 12-volt wired up liquid propane gas detector. So again, if there's any gas leak and it's building up inside those cupboard units and not getting through the dropouts, that should alert me. So yeah, I'm a little bit conscious about making sure it's that my tin box is not going to become an explosive tin box. So that's looking in the back doors there. You can see you've got the manometer there. And I'll just give you a little sort of overview on how that works for me and how I can just regularly, at any time I want, check the integrity of my gas circuit. And might be a bit of an overkill, but I think that was £8 that bit of kit, and worth it in my mind. So how it works then. So with the gas bottles turned off, I open up the isolator valve to manometer and then turn on gas appliance so it levels out, depressurize the system and levels out manometer levels. Then very carefully and slowly open up the valve on the gas bottle to pressurize the system, and you see one of the arms, the manometer climbing up there. So there we go, till it reaches pressure. And once it's at the top and your gas bottle's all the way open, you then close the gas bottle back down again. And what you're wanting is that level to do exactly as it's doing there and staying firm rather than dropping back down again. If it's dropping back down again, but when you turn the gas bottle off, it means you've got a leak. And last but not least, in the main habitable area, a couple of detectors. I've got a smoke detector there, just in case something starts smoking at night, and a carbon monoxide detector, just to make sure I've got everything buttoned down. So that's my gas installation. Hope there's some stuff there as of use to you.
Okay, an epilogue. I think the first and only chapter with an epilogue. Regrettably, I'm having to do this because I was advised I needed to take something out of the resource clip we've just seen. So I've done a last minute edit. And it's all about health and safety, of course it would be. And I said right at the beginning, I'm not going to patronise anyone with health and safety stuff. But I was advised to take out from there. I had references to 2 British standards that were in the resource library, which I've now removed. And I was advised to take them out. One was concerning ventilation requirements for leisure vehicles, and the other one was concerning gas bottle installation or LPG installations. And I was advised to take them out because I was deemed to be setting myself up as an expert, which I'm not, and things go out of date. And in fact, what triggered it is the ventilation standard that I used did get superseded. I've seen the latest one; it's almost identical. In all practical terms, it is identical, but that was where it came from. Also, there's a little bit of complication with conversions, and that is it's not so stringent. So some of those regulations apply only to commercially built vehicles. Some of them only apply when the vehicle is going to be hired out. And so there's a little bit of exemptions on some aspects for camper vans that you convert yourself. But I chose to adhere to all the regs. So what I'm going to do is I'm just going to go through very briefly the key aspects of those two documents that apply when I built my van, and you can take a view. It's easy to get up-to-date copies of the regulations. You get them on the internet. You can just buy the standards from the BS library, or I found mine posted on a camper van conversion forum. Okay, but let me just go through the key elements in. Starting off with leisure accommodation vehicles safety ventilation requirements, and that is BSEN 721. So if you want to do a search on that, see what the current standard is, BSEN 721, leisure accommodation vehicles safety ventilation requirements. So, excuse my glasses, old age doesn't come on its own. Let me tell you the 3 key things you've got to hit to comply. The first is you just need to have a renewal of air for the occupants. Now, if you haven't got a bulkhead across your van, and almost certainly won't, you're going to meet that in any case, because modern vehicles require that so people don't fall asleep at the wheel. So you get that. That's going to be the easy one. The next thing you need to do is a supply of air for combustion for appliances that are not room sealed. Now that will be something like your hob. Okay, so it's not room sealed. It's drawing air in. And pumping its combustion process into the general air. And thirdly, you'll need to have a provision for the evacuation of products for combustion that are not room sealed, like your hob. You haven't got to worry about your fridge, because that's got a vent, goes straight out to the outside world. Ditto with your water heater, because your hob is just blowing stuff out into the van. Now, the requirements are not onerous. If you're using non-forced air systems, and I say for our hob, we have actually got an extractor over the top, but in any case, even if you haven't got that, it's not onerous. So what it's saying, for a van between 5 and 10 metres squared, which is what ours was, your minimum high level ventilation, which can be a roof vent, is 10,000 millimetres squared. And the minimum low level ventilation is 1,500 millimetres squared, tiny. So it's quite easy to hit that. And if you've got a bigger van than that, between 10 and 15, it's 12,500 millimetres squared. That's considerably smaller than a roof vent, and 2,000 for the from the low level. Okay. So, and that's for each individual compartment. So, and that excludes your bathrooms. So you can take that bit out when you're calculating your foot area, and bathrooms are not required to have that. So that's quite easy, and there's some sort of variations around. If you can't do this, you could do that instead in there. But my view is, it would be well worth just doing a search on the internet to find this information. Now there's another requirement in there, and that is for where you have got outside world vents, so like your water heater and your fridge, where you've got a vent going to the outside world. The grill on the outside must be at least, or the vent must be at least 300 millimetres, a foot from a standard opening, such as a window or a door. So it's quite easy for me to meet that in my design. So that's really what that one's about. Not difficult at all. You can take a view on what you want to do. I'm a bit paranoid with gas. I hit every one of those, and you can choose to do that or otherwise. The second one is about installing the gas bottles. Key aspects of those are the gas has got to be travelling in an upright position. Okay. Secondly, the regulation varies depending whether you can access your gas from the inside of your vehicle or not. If you can only access it from the outside, then the ventilation requirements, the drops I talked about, must be at least 2% of the compartment size. So remember I talked about the dropouts? So my hole was that big, and it's about twice what I needed to drop to the outside world. It's 2%. But if you've got a drop in, so fresh air can come in as well, it only needs to be 1%. I've got both, and I've got more than I need. Okay. Now, if you can access your gas from the inside as well, then the hatch on the inside must be sealable, and in addition, you need an upstand from the bottom of your hatch, inside hatch, to the floor of your gas compartment, at least 50 mil. So what it means is if there is any leak, it's got time to get through the dropouts before it comes up and starts coming back through once you open it up. Okay. If you can do that, then you can carry, the compartment can carry a maximum of 2 bottles, each having 16 kilograms. Now that's huge. I've only got 2, 4.5, and that's plenty. So you won't need to do that. Furthermore, what it's saying is if you cannot provide that ventilation described above, you can still access from the inside, but you need a ducting going out. So you've got a duct taking your any leaks out, and you can only have 1 cylinder of a maximum of 7 kilograms, and that ducting must have a minimum diameter of 20 millimeters. Okay, and the length must not be more than 5 times the internal diameter. So it's not a very big duct. If you take my design and don't put any access on the inside, I can actually do that. I put an internal access, but if you don't have that, you haven't got to worry, because you can only get to the bottles from the outside of your van through those rear doors. So that was how it was when I built mine. Things change. It's worth going on the internet to get the up-to-date one. Safety is important. I'm not missing that at all. I just wish I could have included that in the resource, but I was advised to take it out. Anyway, I'll leave it at that. So, chapter 13, gas installation, absolutely nothing to say about that. It's been working fine, and I would say the decision to have 2 small bottles as opposed to 1 bottle, definitely right. A friend of mine has done it the other way around. A couple of times she's run out because she's misjudged what she had in there. It's a little bit more expensive to buy the gas, but you're not using massive, are you? So I would definitely say I think it was right to have 2 small bottles. I've always got one I can swap through, and then get the other one topped up when I get to a place where I can. So that's all I've got to say about the gas installation.